Today we are going to look at the quadratic formula. The quadratic formula basically does this. If we have a quadratic equation that we are trying to solve or to factor, which we've spent much of the last week looking at, we can run into a couple different scenarios. Number one, a quadratic is hard to factor, or some quadratics are actually impossible to factor. So what we want to do is we want to have a way to factor, or more importantly, to find the answer to an equation when it's not easy to factor. So that's when the quadratic formula comes into play. The quadratic formula is, as we know, we can have up to 2 answers. So the quadratic formula, now the quadratic formula assumes this. It assumes that the equation is of the form ax squared plus bx plus c equals 0. So you have something times x squared plus something times x plus something equals 0. The only thing that is true is that a can't be 0. A can't be 0. Because if it's 0, then it's not a quadratic. Then we're talking about a line, and lines are really easy to solve. Linear equations are very easy to solve. So if we have a quadratic equation of the form ax squared plus bx plus c equals 0, here's how we can do it using the quadratic formula. The quadratic formula, and this is something that, you don't have to memorize it because you'll be able to use your formula sheet for your test, but it's helpful if you memorize it just to do the questions. The quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. The plus or minus basically is a way to say that there can be up to 2 answers. There might be one answer, there might even be no answers, but there could be up to 2 answers. So how do we use a quadratic formula to solve this equation? 2x squared minus 6x plus 3 equals 0. If we were going to answer this question, we'd be looking for two numbers that multiply 6 and add to negative 6. There are no such numbers, so we can't factor that even if we wanted to. So we need a way to do this if we can't factor it. That's where the quadratic formula comes into play. So the quadratic formula, again, is x equals negative b plus or minus square root of b squared minus 4ac all over 2a. And I write it out every time I use it at the beginning. The reason I do that is so that I can remember it. If I'm writing it out all the time, I'm going to have an awfully hard time forgetting how to use it and what it is. Now, once I've written that out, it's important to understand what's A, what's B, and what's C. So, what's A, Sky? What's A? So if we're looking at a formula or equation of the form ax squared plus bx plus c equals 0, in this equation, which one is A? Yes, A is 2. Malcolm, what's B? Negative 6. Have to make sure to get the proper sign. It's not just 6, it's negative 6, and C is 3. So we have to substitute those values of A, B, and C into the quadratic formula. And let's go ahead and do that. So x equals negative b, so that's negative 6, which is kind of trippy to think about, but it is plus or minus root of negative 6 squared minus 4 times 2 times 3 all over 2 times a, which is 2. So that's the first step. That's where we substitute all of our values. Minus minus 6 plus or minus root of negative 6 squared minus 4 times 2 times 3 all over 2 times 2. And now what we're going to do is just use order of operations in order to help us figure it out. Okay? Now I understand this. If you've got a graphing calculator, you've got Desmos, you can actually answer this question without the quadratic formula. But again, while this course is all about technology, it's also about how to solve questions, and we can't just rely on technology all the time. So, so x equals, this is going to become positive 6 plus or minus the square root of, anything squared is positive, so 6 squared is 36, minus 4 times 2 times 3, which is 24, all over 2 times 2, which is positive 4. So this looks a lot less tough now because we've done a little bit of the heavy lifting and simplified it quite a bit. We still need to subtract. The next thing we need to do is we need to subtract inside the square root. We need to take those numbers away inside the square root. So let's go ahead and subtract those numbers inside the square root. X equals 6 plus or minus the square root of 12 all over 4. And that is as good as our answer gets before we get to the real thing. Now, how we treat this now is we have to split this off into two different things because there's a plus and a minus. So we have to look at both of those separately. First, the plus. So 6 plus the square root of 12 over 4, or 6 minus the square root of 12 over 4. Now, we can figure out what that is with any kind of calculator. If you want to use the graphing calculator, you can probably type that in all at once. You could type in 6, you could type in bracket 6 plus the square root of 12, bracket divided by 4, and it'll tell you exactly what the answer is. Likewise, you can also go 6 minus the square root of 12 all over 4 using brackets, and we can do that all in one step. Most scientific calculators will also allow us to do that all in one step, but we must use brackets to do it properly. It is important to do this all in one step, or to carry forward lots of decimal places on the square root of 12. We can only and should only round, really. We should only round to 2 decimal places with our answer. So if I use brackets here and go 6 plus square root of 12, and then I divide it by 4, I get to 2 decimal places, I get 2.07 as one of my answers. My other answer is going to be wait a second here. Wait a second here. I just want to make sure I'm doing this right here. I don't know what I was thinking. I really don't know what I was thinking. This isn't the right answer for the first one. This isn't the right answer for the first one. Right answer for the first one is going to be 2.37. Anyone else get that? 2.37 for the first one? You did, Malcolm? Okay, good. Did you get the second one then? 0.63? Okay, good. 0.63. So those are our answers. And like I said, we can figure out what those answers are all in one step on the graphing calculator. If you want to find out the square root of 12 was, you'd have to round it to probably 4 or 5 decimal places because you don't want to really round off until the very end in order to make sure that your final answers, which is the 2.37 and the 0.63, are as accurate as possible. When we do several calculations, it's important not to round too early. Okay? All right, two more questions. Two more questions. Another one, exact same thing here, except there's a slight little twist. The slight little twist is the 3's over here. So we have to bring everything over together. So that's 12x squared minus 8x minus 3. So it becomes negative 3 when we bring it over to the left side to reunite it with the rest of the quadratic equation. And that's what we have. And using that equation, we can go ahead and use the quadratic formula to figure out the values of x that work. And there might be none that work. There might be none that work, but we don't know until we use the quadratic formula. So, quadratic formula again is x equals negative b plus or minus square root of b squared minus 4ac all over 2a. Write it enough times and you will not ever forget it. Now we have to go ahead and substitute our values of a, b, and c. It doesn't hurt. It doesn't hurt to write them down separately as well. So in this question, a is what? Yep. B is what? Negative 8. C is what? Very good. Very good. So 12, negative 8, negative 3. Plug them in, see what we get. Okay. So let's do it. X equals negative b. So that's negative 8, which is just positive 8. We could just write that down. So positive 8 plus or minus root of b squared. So that's negative 8 squared minus 4 times a, which is 12, times c, which is negative 3. And that's all over 2 times 12. If we simplify, we're going to get 64. We have to be aware of the signs in the radical. We have a minus, so it's kind of like negative 4 times 12, which is negative 48, times negative 3, which is going to be positive 144 all over 24. If you miss that positive 144, you'll end up getting a negative underneath the radical. And of course, you can't take the square root of a negative number, so then you'll kind of be hooped. So you just have to be careful with your signs. But you know what? There will be times when you do get a negative underneath the root. And in those cases, all that means is there's no answers to the question, which also means that if you graph that quadratic, there would be no x-intercepts. So we'll go ahead and add those numbers together. So that's going to be 8 plus or minus the square root of 208 all over 24. And the next step, just like last time, was we'll turn that into two separate expressions. One will be 8 plus the square root, one will be 8 minus the square root, and both will be divided by 24. So x equals 8 plus the root of 208 all over 24, 8 minus the square root of 208 all over 24. So when I do that, I get 0.93 if I'm writing it to two decimal places. And negative 0.27. So those are our two answers that represent the value of x, okay, using the quadratic formula. So using the quadratic formula is fairly straightforward. It really just requires putting numbers in and making sure we do stuff in the right order. As long as you do that, you shouldn't have any issues. We got one more question, which kind of turns this into applied math, because applied math is all about answering a type of real world problem. So here's the real world problem. A cannon is shot into the air. An equation that models the height of the cannonball, ht in meters, t seconds after being fired from the top of a hill, is given by negative 4.9 t squared plus 25t plus 18. At what time does the cannonball reach a height of 10 meters? Okay. So we have to use this to come up with a quadratic equation, and with that quadratic equation, we'll use the quadratic formula to help us solve it. All right, let's do it. So, in this function, ht represents the height. We are asked, when is the height? 10 meters. So this is a height. So we can replace the h of t. So in other words, we want to know when 10 is equal to negative 4.9 t squared plus 25t plus 18. So we're just setting the quadratic formula that represents the path of the cannonball equal to 10. We want to know when it's equal to 10. So really what we want to do is we want to find the value or values of t that make that equal to 10. So what we need to do then is we need to bring 10 over to the right side to have everything on one side and 0 on the other. So I'm going to bring 10 over to the right. So negative 4.9 t squared plus 25t plus 8. Because when 10 comes over, it becomes negative. 18 minus 10 is 8. And now we have a quadratic equation. With that quadratic equation, we can use the quadratic formula. And this is another example of a question that we wouldn't factor. We have that negative 4.9, that decimal, as a coefficient on the squared term, which would make this really quite nasty. We do have to make sure just to kind of keep our wits about us, Because the first two questions, we've always been solving for x. We wanted to know what x was equal to. In this question, we're not solving for x. We are solving for the letter t. So it's a very, very small little thing to consider. But when we write out the quadratic formula, we've always started it as x equals ba 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 ba. What we're going to do with this one is we're going to write it as t equals negative b, same thing, plus or minus the square root of b squared minus 4ac all over 2a. So the formula itself is the same. We're just leading it off by saying t equals, not x equals. And again, it's a good idea just to write down what A, B, and C are, so it's easier to figure out. So A, B, C. What's A? Very good. What's B? Yep. And C? 8. So there we go. So we just throw those in for A, B, and C and figure out what T equals using that. So T equals negative B, so that's a negative 25, plus or minus square root of B squared, that's 25 squared. My square root might not be long enough. So minus 4 times A, which is negative 4.9, times C, which is 8. So I'm going to make that bigger and make that bigger, all over 2 times A, and A is negative in this case, so we're going to put 2 times negative 4.9. So it's going to be a little bit messier because we are dealing with a decimal, and so our calculations are going to be using decimals. So we just have to be careful to do that properly as we go through the question. So, same thing as always. We're going to start off by simplifying the inside of that square root. 25 squared is 625. We have two negatives later on, so that's going to become positive. It's going to be 32 times 4.9, which is going to be, I think that's going to be 156.8, but can I have some verification from the crowd, please? What's that? 156.8? Okay, cool. All right, so 156.8. If I'm going through this and I'm making any mistakes, guys, please help me out here. So 2 times negative 4.9 on the bottom is going to be negative 9.8. Simplifying what's underneath the radical there, we're going to get the square root of 781.8, I think, all divided by negative 9.8. So again, making sure we are going to split this up into two. We are going to split this up into two here. So t equals negative 25 plus the square root of 781.8 all over negative 9.8. or negative 25 minus square root 781.8 all over negative 9.8. Bell's going to ring in a minute, so we're just, again, I'll just ask you to be patient as we finish this example, because it will be done right away. Square root of 781.8 minus 25 divided by 9.8 negative is going to give us, interestingly enough, the first time is going to be negative 0.30 seconds. That's the first time. And over here, we're actually going to get positive 5.40 seconds. So the question is like, think about this for a second. If you shoot something up in the air, it comes up and then comes back down. So what this tells us is that there's some kind of a hill. The cannon is right here. It shoots the cannonball up, it comes back down, and that 10 meters is somewhere around here, and it touches that line only once, and that one time it touches it is at 5.40 seconds, because there's no such thing as negative time. So the answer to this question is 5.40 seconds. So you can do your homework. It's on pages 427 to 429, numbers 1 to 13. We're going to do quadratic word problems after the weekend. It's all word problems. We'll go over a few of them, and then we'll give you time to work on them for a class or two.